Question 4. Figure 4.1 shows compounds J to M, each of which contains 4 carbon atoms. Here we have a carbonyl. Okay. In fact, I can give them names. This is C, 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 C. Those are 4. So we can have butanol. This is butanol, and aldehyde. Then here we have, this is 1, 2, 3, 4, butanone. This is butanone. You don't have butan 2 on, because even if you put it here, this will be now 1, then that will be 2. So it's still the same. So I will have butanone, which is a ketone. These 2 are carbonyl compounds. Then here, this is butan 2-ol. This is an alcohol. Then this one is butanoic acid. Butanoic acid, which is a carboxylic acid. Then the table 4.1 gives details of tests on J and M. In each test, only 2, J to M. In each test, only 2 compounds give a positive result. So we are supposed to complete the table. All right. The first one here, acidified potassium dichromate. So this one here is an oxidizing agent. So it is going to oxidize aldehydes, does not oxidize ketones, does not oxidize it doesn't oxidize carboxylic acids, but can oxidize an alcohol here. So it can oxidize this one too, a ketone. Actually, it will give you K if it oxidizes L. And then when it oxidizes J, then it will give you M, the carboxylic acid. You see that? So the positive test here is going to be orange solution, because acidified potassium dichromate is an orange solution. So orange solution turns green. It turns green because here oxidation occurs. We see chromium 6 and then going to chromium 3. So it's an oxidizing agent, so for it gets reduced. So the oxidation state moves from 6 then to 3. So that is that. And this one is orange, then this one here is the green. You see that? But you're not supposed to show this one. You just write this. Then next we have alkaline iodine. So alkaline iodine, to give a positive result, we must have, there must be a CH3 CHOH group, or for carbonyls it has to be CH3 then CO group. So these groups have to be there. If it is an alcohol, it is this. Then ketone, it is like this. And then we get a yellow precipitate. That yellow precipitate is CH3 triiodomethane, which you get from here. This methyl group here is the one. So first of all, all the hydrogens there are replaced by the iodine, the 3 of them. Then from there, hydrolysis occurs, and then you get this one here. So we are going to have, let's look through. Where do we get the CH3? There is a CH3 here, then CO. You see that? So K is amongst them. I'll write it down. K. It has this group. And then when we go to the alcohols, of course, this one is not going to have, because this is CH2 here. You see? It's not. The only aldehyde, usually this one is common. This one here is in ketones. Okay? But for the only aldehyde that is going to give a positive test here, it is the ethanol when we have an H here. So that means there is a CH3CO. It is only ethanol for aldehydes, nothing else. Then here, there is a CH3. Do you see it here? Then there is a hydrogen here, and then the OH. So even L is going to give us. So we shall say K and L. Of course, carboxylic acids, no. It has to be an alcohol or a carbonyl. And then the next one here, they are saying orange precipitate, but then it is J and K. Now, if you look at J is an aldehyde and K is a ketone. So the one that gives a positive test with both of these ones, that orange precipitate, that is 2,4 dinitrophenylhydrazine. So we write 2,4. Remember, when you are writing a letter and a number, you have to put an hyphen. So 2,4 dinitrophenylhydrazine. Sometimes you can abbreviate it to 2,4-DNPH. Even that one is marked. Then sodium. Sodium reacts with alcohols and carboxylic acids. And carboxylic acids. Okay, so which alcohols do we have? We have L and then carboxylic acid M. So we shall put L and M. When it reacts with an alcohol, this one plus CH3, then CHOH, and then CH2, CH3, we are going to get a salt here. We call it sodium alkoxides. So we get, this is CH3, CH, then O, and then we can put the Na. In fact, let me just write it here. O, then the Na, minus, plus, and then it's something like that. Now we are going to get hydrogen here given off as a gas. So because this one is a gas given off, then I'm going to put effervescence. Effervescence. The same to carboxylic acids. We have CH3, CH2, CH2. Remember, it is butanoic acid. Then we shall get CH3, CH2, CH2, then COO, Na. You can put a minus here and a plus, but it's optional. Then plus also a gas, you see, but it doesn't react with anything else. So that is what we have, effervescence. You don't need to confirm to us that a colorless gas that gives a pop sound, because that is the hydrogen, just effervescence, that's all. Part B, K reacts with hydrogen cyanide in the presence of potassium cyanide catalyst forming N. Complete figure 4.2 to show the mechanism for this reaction. Include charges, dipoles, lone pairs of electrons, and Curry alloys as appropriate. So what we are going to have here, oxygen is more electronegative compared to carbon. And since there is a lone pair here, which is going to be taken up, then you have to show the dipoles. So the one which is more electronegative takes the electrons and then it becomes partially negative, and then this one which appears to be losing becomes partially positive. That means this one can give a way for these electrons to come to it, and of course the pi system has to first break because there is limited rotation here. So the moment you bring in electrons, this one has to break, and then from there we are going to have H3C. Then this one is O, then minus, and then here we have gotten the cyanide, then C2H5. That is the intermediate, which has its full mark. Okay, then from there we can have a lone pair here, which can be given to the proton, okay, which comes from hydrogen cyanide. You can actually write it like this. You put hydrogen cyanide and then this one comes off like that. It is the same thing. You can either put hydrogen ion, take away this one just like that, or you can put hydrogen cyanide like that. But if I let it be just like this, then I don't need to add on anything here. You see that? If I put hydrogen cyanide, then I'll have to add plus Cn, meaning that which came in here, okay, which appears to be consumed, then is regenerated here. That's why they are saying a catalyst. So you need some trace amounts of what? Potassium cyanide or sodium cyanide. So that is that. Identify the class of compounds, the class of compound of which N is a member. This one is what we call hydroxynitriles. It's a nitrile because we see this one here. Hydroxynitriles. N has a chiral center. Explain what is meant by the chiral center. Chiral center, you can see that this group is different from this one, is different from this one, and also this one. So that is a carbon attached to 4 different groups. A carbon atom with 4 different groups attached to it. As simple as that. This has been it for this paper. Thank you so much for watching. May God bless you. If you find the content very helpful, kindly like, share, and even subscribe. See you in the next video.